Hello everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 1, which is a pure Mathematics 1 for February-March 2019, and the code is 9709/12. So let's get started. Okay, so for question number 1, the coefficients of x cubed in the expansion of degree 5 of 1 minus px is negative 2160. Find the value of the constant p. Okay, so since now you are given the coefficient for x cubed, so I will be doing the binomial expansion. Right, so the formula is basically 1 plus ax, or 1 plus, you can write a plus b degree n. That is going to be a degree n plus nc1, a degree n minus 1, b degree 1, plus nc2, a degree n minus 2, b squared until b degree n. Okay, so for this case, to make it to the similar form, I will write this as 1 plus negative px degree 5. So now my a is 1. Okay, so my a is 1, then the b is minus px. When you compare these two forms. So from here, I will be getting 1 degree 5 plus 5c1. Okay, 1 degree 4. Basically, 1 degree 4 is 1. So you can just ignore it. Then times minus px degree 1 plus 5c2. Now we just need to get x cubed. Okay, then 1 cube, then minus px squared plus 5c3, 1 squared minus px cubed. Okay, so we do not need to get the full expansion, just up to the x cubed. Then from here, when I simplify, first term is 1. The second term, basically, 5c1 is 5. 1 to any degree is 1, and there is a negative px here. Therefore, I will get negative 5px, sorry. Then the next one is 5c2, you get 10. Then the 1 cube is 1. Square of minus px is basically positive p squared x squared. And same goes to 5c3. 5c3 is basically positive 10, but then because of the cube of minus here, it becomes a minus. So I will be getting minus 10p cubed x cubed. Okay, then from here is given that the coefficient for x cubed is negative 2160. So coefficient of x cubed equals to negative 2160, which means minus 2160, it is same as minus 10p cubed, because that is my coefficient of x cubed in the expansion. Then from here, the minus can be cancelled off, and then the 10 can be cancelled off as well. So therefore, p cubed is 216, and hence your p is going to be cube root of 216. That is going to be 6. Okay, so done for question number 1. Question number 2, the curve with equation y equals to fx passes through 2 points. It's given that f prime x is kx squared minus 2x, where k is a constant. Find the value of k. So now, since you are given f prime x, then I will start with the derivative. Now, from derivative to get fx, we need to integrate. Okay, therefore, your fx is integration of kx squared minus 2x with respect to x. Then this is going to be kx cubed over 3, then minus 2x squared over 2 plus c, because we are using this formula, integrate x degree n, or kx degree n dx. So here is going to be k bracket x degree n plus 1 over n plus 1, then plus c, provided the n is not minus 1. Then from here, I will simplify the 2 and half. That is going to be kx cubed over 3 minus x squared plus c. This is my fx. And now it's mentioned that the fx passes through 2 points. So I will consider first point, which means my x is 0 and my fx is positive 2. Then from here, I will substitute into the previous equation. So left side is 2, right side k times 0 cube is over 3, it is 0. Then the second term is also 0, then plus c. Hence your c equals to 2. Okay, so now I rewrite. My fx is basically kx cubed over 3 minus x squared, then plus 2. And now substitute another point, 3 and minus 1. So now when 3 and minus 1, that means your x is 3, your fx is minus 1. So again, from the previous equation, it will be minus 1 equals to k over 3 times 3 cubed. Right? Instead of writing kx cubed over 3, I will factorize the k over 3. And then minus 3 squared plus 2. Then from here, you will be getting minus 1. The 3 cubed over 3 is basically 3 squared. That is 9. So I will be getting 9k. Then minus 3 squared plus 2, that is minus 9 plus 2, that is minus 7. So from here, I will get 9k equals to minus 1 plus 7, that is 6. So at last, my k equals to 6 over 9, that is 2 over 3. So done for this question, number 2. Question number 3. In the diagram, CXD is a semicircle of radius 7. So CXD is here. This is semicircle. Right? Radius 7 with center A. So this is a center A. That means CA is 7. Then AD is 7. Now, this is the semicircle. The straight line YABX is perpendicular to CD. Okay, which is here. Perpendicular. And the arc CYD. So CYD is over here. CYD is part of a circle with center B and radius 8. Okay, so here is the center. That means this is 8. Here is 8. Right, now find the total area of the region bounded by the two arcs. So which means we need to find area of this arc, area of this sector plus area of semicircle. So if I plus these two together, you will see the triangle is added twice. Okay, which is here, the triangle. This part is added twice because you have two colors. Alright, so the idea is you find the sector area of CBDY, which is orange color. You plus with the area of the semicircle, which is a green color. Then you minus the area of the triangle. Okay, because the triangle is counted twice. We just need to count once. Right? So now, first of all, to get the area of the sector CBYD, I need to find out what is my angle here. What is my angle CBD? But before I get the angle CBD, okay, so now here, let me erase all this first. Then it will be half of the, or probably I will say, angle of CBD is double of angle CBX. So I can find CBX because this is a right angle triangle. Okay, the opposite side is given 7, and then the 8 is hypotenuse. Then here you will be able to find the angle CBA. Right? So now I will start with angle CBA. This is 7, here is 8. So sine angle CBA or ABC, right, ABC equals to 7 over 8. Then from here, I will get angle ABC is basically 1.0654 radians. Right? So from here, I will write my angle CBD. Right? CBD is this blue color. Is double of angle CBA or ABC. So angle CBD equals to 2 times of angle ABC. that is 2 times 1.0654, then you will be getting 2.1308 radians, right? So now from here, I can easily get my area of sector because our formula is basically R, okay, sector with the radius R and center and the angle theta, the area is basically half R squared theta. So now we have found the theta. The theta is basically this blue color. Okay, we have found it. That means the R is 8, right? So you look at the whole orange color labeling. So that means I will write total area equals to area of the sector CBDY plus area of semicircle CXD. Then I minus area of triangle. So the triangle is CBD. Okay, CBD. Alright, so for the first one, it will be half R squared theta. So that means that is half. Your R is 8, which is the orange color, the radius, 8. Then the R is basically this angle, 2.1308 squared. Then plus area of semicircle. So area of semicircle is basically, now for your information, if let's say it is a circle, this is the R. So area of circle is basically pi r squared. So if half circle means half pi r squared, right? So I will just write my R is 7 right now, because that is the radius of the circle. So it becomes half pi 7 squared. Then minus area of triangle, okay, just for information. If let's say this is a triangle, here theta, this is AB, then my area is basically half AB sine theta. Okay, so from here, I know that I have found this whole angle, alright, the CBD. So then the radius, I mean not radius, these two sides, the two sides bounded by the angle will be 8. So I will get half times 8 times 8, then sine the angle CBD. So here it will be half 8 sine angle CBD. CBD is 2.1308. Right, so from here the first value is going to be 68.1856. Then the next value is 76.9690. Then the third value is going to be 27.1121. Then here is going to be 118.0425. And we always round up the answer to 3 significant figures. That is going to be 118. So this is the area bounded by the two arcs. Question number 4. A curve has equation y equals to degree of minus 1 for 2x minus 1 plus 2x. Find dy dx and d squared y over dx squared. So now here, for the dy dx, I'll probably copy the question first. Now when we need to differentiate, we use this formula. Differentiate fx with degree n. So you have to bring down the n, then rewrite the function. The degree becomes n minus 1 and differentiate fx to get f prime x. Then from here, I will bring down the minus 1. So now my dy dx, bring down the minus 1, I will just write minus, rewrite the whole function. The degree you minus another 1. So minus 1 becomes minus 2. And don't forget, you need to differentiate the function inside the bracket, which means when you differentiate 2x minus 1, that is 2. Now, for the second term, when you differentiate 2x, so differentiate cx or kx with respect to x, that is going to be just k. So therefore, I will be getting plus 2. Then now from here, when I rewrite, I will just get minus 2, 2x minus 1, negative 2, plus 2. So you may leave your answer in this form because we need to get the second derivative. So now my second derivative will be the differentiation of first derivative. So now again, this minus 2 will be brought down. So I get minus 2, then 2x minus 1. Now the degree, instead of minus 2, now you have to minus another 1. It becomes minus 3. And inside the bracket, when you differentiate 2x minus 1, that is 2. So the plus 2 becomes 0. Then from here, when you simplify, basically minus 2 is positive 4. Positive 4 times 2, it becomes 8. So I will be getting 8 bracket 2x minus 1 to the power of negative 3. So you may leave your answer in this form, or you change to 8 over 2x minus 1 cube. Okay, as your final answer. So that's all for the first part. Now part 2, find the x-coordinates of the stationary points. So whenever you see stationary points, means that dy dx equals to 0. And showing all necessary working, determine the nature of each stationary point. So now look at the question. Points means more than one point here, and the nature means either maximum or minimum. Okay, then now we need to refer back to the previous solution because we have found the dy dx over here. I will rewrite. So this dy dx is basically minus 2 times 2x minus 1, degree of minus 2, then you plus 2. Okay, then now from here I will rewrite. This is basically minus 2 over square of 2x minus 1, then you plus 2. And now stationary point means dy dx equals to 0. So which means minus 2 over square of 2x minus 1 plus 2 equals to 0. So the minus value, you can just move to the other side. Therefore, I will get 2 over 2x minus 1 squared equals to positive 2. Then from here, the 2 can be cancelled off from both sides. So now it's like you are dividing the whole equation by 2. Then from here, the denominator will be moved to the other side. So I will be getting 1 equals to 2x minus 1 squared. Now, you can either do expansion, quadratic expansion, to solve the 2x because it's mentioned stationary points, right? So you will be getting more than 1x here. Or another option is you just move the square to the other side because plus minus square root. So I will just move the square to the other side. Therefore, it's plus minus square root 1. So I will be getting 2x minus 1 is plus 1 or 2x minus 1 is minus 1. Okay, so the minus 1 move to right side for both cases. So the first term is 2x equals to 1 plus 1, which is 2. Or the next one is 2x equals to 0. Then here I get 2x values. Okay, as per requested in the question, just find the x coordinates. So we have done for the x. And now for each x, we need to determine the nature. Okay, so for the nature, we need to refer to the second derivative. So now when x equals to 1, my d squared y over dx squared. Again from the previous part. So refer back to first part. Dy dx is always 8 over 2x minus 1 cube. Right? So here I will write 8 over 2x minus 1 then cube. So from here I will get 8 over 1. That is 8. More than 0, that means you are getting a minimum point. Okay, so minimum. Then when x equals to 0, your d squared y over dx squared is going to be 8 over 2x, x is 0, minus 1 and cube. So here becomes 8 over minus 1 cube, that is minus 8, which is less than 0, and the conclusion is maximum. Okay, so that's the nature of the stationary points. Okay, question number 5. Two vectors u and v are such that u is q26, v is 8, q minus 1 and q squared minus 7. Where q is a constant, find the value of q values, so it means that more than one value here for which u is perpendicular to v. So when u is perpendicular to v means that u dot v equals to 0. The dots product equals to 0. So therefore I will write q26 dot 8 q minus 1 q squared minus 7 equals to 0. So the dots product is simple. You just multiply each component, okay, then plus all together. So that means you will be getting 8 times q, or q times 8, plus 2 times q minus 1, plus 6 times q squared minus 7 equals to 0. And do expansion. So first term is 8q. The second term I will be getting 2q minus 2. Third term, just do expansion to get 6q squared minus 42 equals to 0. Then now when you simplify all this, it will be 6q squared. Now here, 8q plus 2q is 10q. So you plus 10q minus 2 minus 42 is minus 44. That equals to 0. So from here, right, the whole equation can be divided by 2. Can be simplified by dividing 2. So you will be getting 3q squared plus 5q minus 22 equals to 0. And now we need to find the q. So then this quadratic equation can be factorized, right? So now to get 3q squared, it must be 3q times q. And then look at the sign here, plus times minus to get a minus. So I will have 1 plus and 1 minus. But then when look at the 5q here, that means I will have to write here is plus, this is minus, right? So the 22 is basically 2 times 11. So to get positive 5q, so here should be 11, so that I get plus 11q, and this is 2. So when you multiply 3q and minus 2, that is minus 6q. So when you add together, the middle is positive 5q. Then the first and last columns here, you just multiply. So 3q times q, that is 3q squared. Okay, and last term minus 22. Now for the factors, you just cross multiply. Or you can just get the roots from the equation, then from the roots you get the factors, no problem. So here you will be getting 3q plus 11 multiplied with q minus 2 equals to 0. Then at last, right? So you let both factors be 0. So 3q plus 11 equals to 0. Therefore your q is minus 11 over 3. Or q minus 2 equals to 0. Then your q is 2. So these are the two q values for which that two vectors are perpendicular to each other. Now find the angle between u and v where q equals to 0. So now I need to rewrite my u and v when q equals to 0. Okay, so your q equals to 0 means your u is 0 to 6. And the v will be 8 minus 1 minus 7. Now, I will let theta be the angle between u and v. So use the formula, scalar products formula, u dot v equals to magnitude u, magnitude v, cos theta. Okay, so basically, we have found the u dot v. So the u dot v, actually you can refer to this too. No, you can refer to this. Otherwise, you can just direct count. Okay, that will be easier as well. So I will write 0 times 8 plus 2 times minus 1 plus 6 times minus 7. That is my u dot v. That equals to, the magnitude is basically square root of each component. So 0 squared plus 2 squared plus 6 squared for the magnitude of u. Magnitude of v is going to be 8 square plus minus 1 square plus minus 7 squared. Then cos theta. Okay, then from here for the left hand side, you will be getting minus 2 minus 42. Then the first square root, that is going to be square root 40. And the second square root is basically square root 114. Then cos theta. So from here, I will get cos theta is basically minus 44 over square root 40 multiplied with square root 114. Then here, your theta is basically a cos of that value. That is 130.7 degrees. So that is the angle correct to 1 decimal place. Okay, question number 6. First part, the first and second terms of a geometric progressions are p and 2p respectively, where p is positive constant. Now, sum of the first n terms is greater than 1000p. Show 2 power n is greater than 1001. Okay, so now geometric progression. First term a is p. Second term is 2p. So we know that, right, from the geometric progression, Tn is ARn minus 1, where the A is the first term. Then from here, I will say my 2p is basically A is P, then R degree N. Right? So, or probably I will just write my R is T2 minus T1. You can use that as well to get the R. So, R is T2 minus T1. Sum of the first n terms, right? That is the Sn. Sn equals to, if your R is greater than 1, modulus R is greater than 1, it will be A bracket R degree N minus 1 over R minus 1. But if it is less than 1, then it will be Sn equals to A bracket 1 minus R degree N over 1 minus R. Okay, so we have two formulas here. It depends on your R value. So now my R equals to T2 over A. Okay, or probably here I write T1. A equals to T1. So then you will be getting 2p over p, that is 2. So since your R is 2 greater than 1, therefore I use the first formula. So that means now Sn is greater than 1000 p is given in the question. That means now our formula is A is P, R degree N, so 2 degree N minus 1 over R minus 1. So over 2 minus 1, which is greater than 1000 p. So from here, the denominator is basically 1. 2 minus 1 is 1. So I will get p brackets 2 power n minus 1 is greater than 1000 p. So then you can divide the whole equation by p. So it means that the p will be cancelled off. And now we need to prove 2 power n is greater than 1001. So which means now when I open the brackets, the left side is basically 2 power n minus 1 greater than 1000. Therefore, the minus 1 move to the other side, you are getting 1001. So we have proven, or we have shown this inequality. Part 2, in another case, p and 2p are first and second terms respectively on an arithmetic progression. So this is arithmetic progression. First term is p, second term is 2p. Now the nth term is 336, Tn is 336. Sum of the first n terms, Sn is 7224. Now write down two equations is in n and p, and hence find the two values. Okay, so for the arithmetic progression, our Tn is a plus n minus 1 d, whereby the d is a common difference, a is the first term. So the d is found by Tn minus Tn minus 1. Okay, so the term minus the previous term, that is the common difference. And the Sn formula is n over 2a plus n minus 1 d. So this is the general formula for sum of the first n terms for arithmetic progression. So what I need to do here is Firstly, I need to use Tn. Use Tn to get the first equation. After that, use the Sn to get the second equation. So done for the first part. Before we solve n and p. So now, Tn is basically a plus n minus 1d. So given 336, my a is p, right, plus n minus 1. Okay, now it's my d. D is t2 minus t1. That is 2p minus p, which is also p. Right? So from here, I will let this be the first equation. Or probably I can just do expansion first. P plus np minus p, which means np equals to 336. Right? Let's say this is the first equation. Now the second equation is getting from the Sn. So Sn equals to n over 2 times 2a plus n minus 1d. So then 7, 2, 2, 4, n over 2, 2a, a is p, plus n minus 1, again the d is p as well. Okay, so now I have to get the second equation. So that means here probably you can just times 2 to the whole equation. Alright, so then you will be getting, so you times 2, then you will be getting left side 1, 4, 4, 4, 8. Then right hand side you have n bracket 2p, here's 2p, plus np minus p. So you may get n bracket p plus np. This is my second equation. And now I need to solve simultaneous equations. Alright, so from here, I will get the n as the subject, right? Or you can get the p as a subject, up to you. So I will just write from first equation, my n equals to 336 over p. Let this be the third equation. Now substitute third into second. So I will get 1,448 equals to 336 over p, multiply with p plus 336 over p, this is my n, then multiply with p. So then I can simplify. The p will be cancelled off. So basically inside the bracket I get p plus 336. Right, so from here, you will, probably I will just times this, move this p to the right side. So I multiply by p. Therefore you get 14448p equals to 336. Or probably I can just times by p over 336. Right, that is easier. So I don't want to write the huge number, so I times by p over 336. So this value you times by p over 336, so you will be getting 43. So 43p. So the first bracket, I mean before the bracket 336p, you times by p over 336, that is 1. So I will just write down the terms inside the bracket. That is going to be p plus 336. Okay, then from here, the p move to the left side. So when you move, it becomes 42p equals to 336. Then your p is 336 over 42. Then you just calculate this value. That is 8. So we have found the p. Now to get the n, substitute into the third equation. So from third, the n equals to 336 over 8. And now you will be getting 42. So solve for this part. Question 7a. Solve the equation 3 sine squared 2 theta plus 8 cos 2 theta equals to 0 for the theta defined from 0 to 180 degrees. Okay, so now since we have degree 2 for the sine 2 theta and degree 1 for the cos, alright, so that means now here I need to eliminate the sine squared 2 theta because the cos 2 theta is with degree 1, so I have to keep that term. So now use the formula sine squared A plus cos squared A equals to 1. Therefore, sine squared A equals to 1 minus cos squared A. This is the identity. Right, so when you compare, basically my A is 2 theta. That means now 3 sine squared 2 theta plus 8 cos 2 theta equals to 0. This becomes 3 bracket 1 minus cos squared. The A is 2 theta, so 2 theta plus 8 cos 2 theta equals to 0. Then now you do expansion. That is 3 minus 3 cos squared 2 theta plus 8 cos 2 theta equals to 0. Then move all the terms to right side to get positive coefficient of cos squared. So I will be getting 3 cos squared 2 theta minus 8 cos 2 theta. The positive 3 move to the other side becomes minus 3. Okay, then from here, this quadratic can be factorized. Right? So instead of quadratic, which is ax squared plus bx plus c, so now the x becomes cos 2 theta. So now I can factorize this into 3 cos squared 2 theta will be 3 cos 2 theta multiplied with cos 2 theta. And then the sign, look at the sign here. Minus times plus will be a minus. And I need to get minus 8 cos 2 theta in the middle term. That means I should get minus and plus here. And then to get the 3, it will be 3 times 1. So I will get higher minus value, negative value. So this is going to be minus 9 cos 2 theta. And the middle term, the next term is going to be plus cos 2 theta. So the middle value is basically minus 8 cos 2 theta when you plus together. Therefore, my factors just cross multiply. And now here you will be getting 3 cos 2 theta plus 1 multiply with cos 2 theta minus 3 equals to 0. And now here you will be getting either 3 cos 2 theta plus 1 equals to 0 or cos 2 theta minus 3 equals to 0, because multiplication of two terms equals to 0 means one of them must be 0. And now when you look at the interval, your theta is defined from 0 to 180 degrees. And now you are solving cos 2 theta. So now I have to get the new intervals. Okay, new interval. So 0 to 180 degrees. Now when you times 2, it becomes 0 to 360 degrees. Right? That means now here, the first one I will write cos 2 theta is minus 1 over 3. The second one is cos 2 theta is 3. So we know that cos maximum is 1, right? Okay, let me check my expansion. Okay, so now here, cos 2 theta equals to 3 means undefined, because maximum value for cos theta or cos 2 theta on any cos graph will be 1. Minimum is minus 1. So now I have to solve this by referring to the new interval. So then I will just draw the quadrant. Now cos negative, which means the angle in second and third quadrant. So now I will write basic angle equals to arc cos 1 over 3. Don't put the minus. The minus is just to show you the quadrant. So this is going to be 70.53 degrees. So which means I got to label these two angles as 70.53. Okay, and now by looking at this interval, it is from 0 to 360 degrees. So therefore, your angle is counted from positive first quadrant until the line. Okay, so for the shorter angle or for the smaller angle, so here it belongs to 2 theta. It will be 180 minus 70.53. That is the angle in the second quadrant. And the angle in the third quadrant, you have to plus. So 180 plus 70.53 degrees. So then you will be getting 109.47. And another one is 250.53 degrees. Now your theta divided by 2. So when you divide by 2, that is 54.7 degrees, and I round up to 1 decimal place, and also 125.3 degrees. So that's the solution for this question. Now part B. The diagram shows parts of the graph y equals to a plus tangent bx, where a is measured in radians and where x is measured in radians, and a and b are constants. Now the curve intersects the x-axis at minus 1 over 6 pi, 0, and the y-axis at 0, square root 3. Find the values of a and b. Okay, basically, for this graph, since the function is given and 2 points are given, then you can just direct replace. Because we need to find 2 unknowns, therefore we need 2 equations. Hence, we get the 2 equations from the 2 points. So from here, my x is negative pi over 6, my y is 0, which means when you substitute into the equation, I will be getting 0 is a plus tangent minus pi over 6b. So then, you will be getting a equals to, now, for your information, tangent minus, okay, we have a formula, tangent minus x is basically minus tangent x. So tangent minus pi over 6b is basically minus tangent pi over 6b. Therefore, from here, my a is tangent pi over 6b. That is the first equation. Now, refer to the second point, 0 square root 3. That means your x is 0, your y is square root 3. Then from here, I will get square root 3, that is my y from this general equation. Then a plus tangent 0. So tangent 0 is basically 0. So therefore, your a is square root 3. Okay, so now substitute this a into the first equation. So from first equation, square root 3 is tangent pi over 6b. Okay, so to get a b, the tangent move to the other side becomes arctangent. So arctangent 3 equals to square pi over 6b. So arctangent square root 3 is basically pi over 3. Okay, you can get it from calculator. Then from here, my b, right? So pi over 3 times 6 over pi. That is going to be 2. So done for the b. Question 8, first part, express x squared minus 4x plus 7 in the form square of x plus a plus b. So this is completed square form, right? So now I need to perform completing the square. So according to completing the square, you need to rewrite first 2 terms, but before that, make sure the coefficient for x squared is positive 1. So after you have rewrite the first 2 terms, what to do is you plus bracket squared minus bracket square, and then plus 7. So now the term inside the bracket will be half of the coefficient of x. That means now here I will be getting minus 4 over 2. Okay, and then you combine the first and third term. Alright, so that will be x. Now, when you look at the third term inside the bracket, that is minus 4 over 2. Minus 4 over 2, when you simplify, that is going to be minus 2. Okay, so with this squared, this term, I have simplified first 3 terms. So now what you need to do is just simplify the last 2 terms. So I will get minus, again minus 4 over 2 is minus 2, you square it, that is 4, then plus 7. So at last, you will be getting x minus 2 squared plus 3. So done for first part. Now, the function f is defined for same quadratic function, but x is less than k, where k is a constant. Find the largest k for which f is a decreasing function. Okay, so now, for your information, your fx is written as this form. Okay, so here I will write fx equals to x minus 2 square plus 3. So you should understand that this x minus 2 squared plus 3 means that you are getting a minimum point because the coefficient for x squared is positive 1. So minimum points with coordinates 2 and 3. We let x minus 2 be 0. That is the x coordinate of the minimum point. And then the y coordinates is basically the plus 3 over here. Okay, so now when you sketch a graph, okay, I will explain using the graph. That means this is 2, 3. Okay, now state the largest k for which f is decreasing function. Obviously, when you sketch a graph and you refer to this graph, the graph is decreasing for this part. Okay, that means the largest x is 2. So x is less than k. That means your x is less than 2, right? So from here, you can just write fx is a decreasing function when x is less than 2. Okay, therefore the largest k equals to 2, because when we compare with this x less than k, x less than 2, which means your k is 2. So that is the largest k. Okay, now the k is now given to be 1, no longer 2. Find the expression for f inverse and state the domain of f inverse. So to get the f inverse, I need to rewrite my fx first in the completed square form. And I let y be fx. Now, to get the f inverse, firstly I need to get the x as a subject. So which means the plus 2 move to left side becomes minus. Plus 3 move to left side becomes minus. So I'm getting x minus 2 squared equals to y minus 3. Okay, and then eliminate the squared by taking plus minus square root. Then now my x, I move the minus 2 to the other side becomes 2. And then I cannot write down the plus minus. I have to decide whether it's plus or minus. So now for your information, the domain, okay, look at this diagram. This is your f. Domain f will be mapped into range f. So if opposite direction, that is your f inverse. That means this is the domain f inverse. This is range f inverse. So from here, I know that domain f inverse equals to range f. But when you look at this whole expression, this is basically the range, right? Because later on, I need to change to f inverse for the left side. And then for the right side, the y will be changed to x. So the range, this whole term will be the range. So look at here, the range of f inverse is domain f. Now your domain f, because your x is less, it becomes 1 now. Okay, which means this is when x is less than 1. So which means your range f inverse, oh, this is your domain f, right? Domain f, x less than 1. That means range f inverse, f inverse is less than 1. So to get less than 1, I have to put minus, right? This is how we decide plus or minus. So this is your expression for f inverse. And now we need to state the range, the domain for f inverse. So again, look at this mapping. Domain f inverse equals to range f. So now I have to find my range f. Okay, so domain f inverse equals to range f. Therefore, my range f, the fx. Okay, so x less than 1. So I'll calculate what is my f1 first. f1 is going to be 1 minus 2 squared plus 3. So this is going to be 4. Right? Now look at the graph. Let's say graph. Here is 1 when the x. And I found that when x is 1, my y is 4. Okay? That means this point is with coordinate 1, 4. So when the x is less than 1 now, x less than 1, that means now my value will be this part, right? Or my y will be greater than 4. So which means now here, basically my range of f is fx greater than 4. Therefore, my domain f inverse, just change the f into x due to this formula. Okay, so done for this F inverse and domain F inverse. Now part 4. The function g is defined as gx equals to 2 over x minus 1, where x is greater than 1. Find an expression for g f x and state the range of gf. Okay, so now gf, or I will write gx first, 2 over x minus 1. Then the fx we have found just now, the completed square form. That is x minus 2 squared plus 3. Therefore, g of x, this is a composite function. That means g of fx, which is g of x minus 2 squared plus 3. So now what to do is you compare. This is gx. Here is g of function. That means now I will replace this x by this whole bracket. Right? So that means it's basically you are getting 2 over x minus 2 squared plus 3. Okay, or probably I can just write I will just write this, then minus 1. This is the simplest form. Then from here, you will be getting 2 over x minus 2 squared plus 3 minus 1 is plus 2. So this is my g of x, simplest form. Now, state the range of gf. Okay, so you may just refer to the domain. Okay, now you look at here. For the composite function, so this is gf, but we substitute f into g. That means this is f, here is g. Now, for the first circle, this is domain f, is same as domain gf. Okay, so then I need to find out what is my range gf now. What is my range gf? That means what is my range gf here? Okay, so if I know what is my denominator, then I can find the range. Right? Now, it's given that your domain g is x greater than 1. So look at here, the domain g is over here. This is your domain g. And at the same time, it is a range of f as well. Okay, so just now we know that your domain g is x greater than 1. Okay, this is x greater than 1. But my range f is fx greater than 4. We have found just now. Right? So here, range f is fx greater than 4. Okay, so now what to do here is I will refer to the point, right? What is the, basically from here you should know that when you look at this denominator, the minimum point is with coordinates 2 and 2, right? So from here, I will say x minus 2 squared plus 2 this is with minimum point 2, 2. Okay, but your domain x is greater than 1, domain for g, right? So to get the range of range of gf, you must refer to the domain of g as well, because this is basically range of g, and at the same time here is also range of gf. Okay, so you may refer to this method. Then now when you refer to this value, let's say I sketch a graph. Okay, so that means this is 2, 2. But then remember, my domain g is x greater than 1. Okay, that means now here I need to find out when x is 1, what is my value. Okay, so I will just write when x equals to 1, my graph, this is 1 minus 2 squared plus 2, that is going to be 3. So what I need to do here is I will write gf1 I substitute back into this whole equation, it will be 2 over 3. Okay, so I know that at this particular point, my graph becomes this part. Because when it is greater than, right? So when you refer to x is greater than 1, and at the same time, when you need to find the range of GF, you may refer to domain as well. No problem, domain F. Okay, so when you refer back to the domain F, where's your domain F? Okay, your domain F is less than K, and now the K is 1. That means I will say that when x is less than K, when x is less than 1, okay, that means here is 1. Coordinates will be 1, 2 over 3. So when you consider this left side, right, 1 or 2 over this graph, okay, 2 over the quadratic, it will be inverse. So now it becomes, okay, this is basically not 2 over 3, this is basically 3, 1, 3. So here becomes 1, let's say here is 1, then this is 2 over 3. If I sketch GF graph, okay, this part increasing, so it will be decreasing, right? But then when you look at the function, your fx, numerator is positive, denominator is positive because of the square, and plus 2. Whenever squared minimum is 0, 0 plus 2, minimum is 2. So I know that it will be positive. And because the original graph, which is a quadratic curve, it is increasing. I mean, from 1 you increase, right? I would say from 1 you increase, which is this part, keep increasing. Therefore, for the inverse or the reciprocal, okay, or I would say 2 over the increasing, it will be decreasing. So when I sketch a graph, it will decrease until close to the x-axis. So this is my x-axis, right? So from here, I will say that so the proper explanation is since fx is greater than 4, then, right, gfx is less than 2 over 3. Here, less. But gfx is never negative. Okay, hence the range, right? State the range. Hence, range of GF, your GF is between 0 and 2 over 3. Okay, so that is your final answer. I'm using this quadratic to explain the 2 over 3. Right? Now, question number 9. The graph shows parts of the curve with equation y equals to square root of x cubed plus x squared. The shaded region is bounded by the curve, the x-axis, and the line x equals to 3. Now, 5, showing all necessary working, the volume obtained when the shaded region is rotated through 360 degrees about the x-axis. So when you rotate about the x-axis, formula is v equals to pi y squared dx because of the rotation is at the x-axis. So now I will write volume equals to pi integrate from 0 to 3 y squared dx. So I square this y becomes no more square root. So that is pi integrate from 0 to 3 x cubed plus x squared dx. And now here you will get pi integrate x cubed, that is x degree 4 over 4. Then the x squared becomes x degree 3 over 3. Limits from 0 to 3. Then from here you will be getting pi. Okay, replace the x by 3 now. So 3 power 4 over 4 plus 3 cubed over 3. Then minus, when the x equals to 0, both terms equals to 0. Then from here, it will be pi. 3 power 4 is 81. So 81 over 4 plus 3 cubed over 3 is basically 9. So at last, you are getting 117 over 4 pi. That is the volume of the shaded region. For part 2, P is the point on the curve with x-axis 3. Okay, x-axis 3. Right, which is here. Find the y-coordinates of the points where the normal to the point's curve to the point at P crosses the y-axis. Alright, so now I will say at P, the x is 3. So because of normal here, right, so now we need to find the dy dx first. That is the gradient of tangent at the point P. So now my y is square root of x cubed plus x squared. So this is same as x cubed plus x squared with degree half. When I differentiate fx with degree n, that is n fx degree n minus 1 times f prime x. Okay, that means now here I have to bring down the half for my differentiation. So dy dx equals to half bracket x cubed plus x squared. Now the degree becomes half minus 1, that is minus half. And differentiate x cubed, 3x squared. Differentiate x squared plus 2x. And now I simplify the negative degree, I move it down. Then I will be getting 3x squared plus 2x in my numerator. And the denominator is 2 square root x cubed plus x squared. Now, I need to find out what is my gradient at the points, the gradients of gradients of tangents at P before I get the normal. Okay, the gradients of normal or the tangent, the normal line equation. So I will write as P, x equals to 3. So now my dy dx, this is a gradient of tangent as P. So replace the x value by 3 first. Then here 3 cubed plus 3 squared. So this is going to be 11 over 4. That means gradients of tangent equals to 11 over 4. So gradients of normal is basically negative 1 over gradients of tangent because they are perpendicular to each other. So gradient of tangent times gradient of normal is minus 1. That means now here is negative 1 over 11 over 4. That is going to be negative 4 over 11. Now, I need to form the straight line. Okay, so when we need to form the straight line, we need to know the point, the coordinates of the points P. And remember, the points P is on the curve now. That means now at P, x equals to 3, the y coordinates will be square root of x cubed plus x squared. So this is going to be square root of 27 plus 9. That is 36. Square root of 36, you get 6. So I know that the point P is with coordinates 3, 6. So when you look at the question, find the y coordinates of the point where the normal to the curve as P crosses the y-axis. So now I need to form the normal line. So equation of normal at P. That is y minus y1 equals to m bracket x minus x1. Or you can use y equals to mx plus c. So use this gradient, negative 4 over 11, and point with coordinates 3, 6. So I get y minus 6 equals to gradient is minus 4 over 11. Then x minus 3. Okay, so now no need to simplify because the question asking for y coordinate when the normal crosses the y-axis. So when crosses the y-axis means that x equals to 0. So now when crosses the y-axis, that means x equals to 0. So I will substitute x equals to 0 into my first equation. So from first equation, y minus 6 is minus 4 over 11 times 0 minus 3. Okay, so from here you will get y equals to minus 4 over 11. This is positive 12. Positive 12 over 11. Then the minus 6 move to the other side becomes plus 6. Then you will be getting 78 over 11. So this is the y coordinate of the point. Okay, now question number 10. The diagram shows a curve with equation y equals to 4x power half. First part, the straight line with y equals to x plus 3 intersects a curve at points A and B. Find the length of AB, which means now, firstly, we have to find the intersection point. Okay, the two intersection points A and B. After you have found the A and B, then we have to find the length. Okay, this is the second part. So basically, we need to solve the simultaneous equations. Alright, so y equals to 4x degree half as first equation, y equals to x plus 3 as second equation. So now, when I equate them, intersection points means simultaneous equations, I will get 4 square root x equals to x plus 3. Now, to eliminate the square root, I will square both sides. So when I square both sides, left hand side, 4 squared is 16. Square of square root x is x. Right hand side, you do expansion using quadratic expansion. A plus b squared. That is a squared plus 2ab plus b squared. Then from here, you will be getting x squared plus 6x plus 9. Then you will be getting x squared. The plus 16x move to left side, move to right side, it becomes minus 10x. Then plus 9 equals to 0. So this can be factorized into x times x, the 9 and minus 10. So minus, look at here, minus times minus is a plus. That means I will have both minus signs. So here 9 and 1. So this is minus 9x minus 1x. So therefore I'm getting minus 10x in the middle, and then plus 9, then this is x squared. Now for the factors, just multiply, cross multiply. And then from here, I will be getting x minus 1 times x minus 9 equals to 0. Okay, so x minus 1 equals to 0, or x minus 9 equals to 0, which means my x equals to 1 or x equals to 9. And now I need to find out the y coordinates. So probably I just solve side by side. So from first equation, okay, to find the y, you can use first or second equation, up to you. So when x equals to 1, my y is 4 square root 1. That is 4. And then when my x equals to 9, my y is 4 square root 9. Square root 9 is 3. 3 times 4, 12. So probably I will let a be 1, 4. And then b be 9, 12. So I found 2 points. Okay, so now the length of AB. So length of AB is square root. Use the formula. Let's say you have 2 points, x1, y1, and x2, y2. So the AB is basically square root x1 minus x2 squared plus y1 minus y2 squared. This is the formula for the length of 2 points. Okay, therefore, I will be getting 1 minus 9 squared plus 4 minus 12 squared. So this is 8 squared, negative 8 squared plus negative 8 squared. So 64 plus 64, that is 128. And hence, you will be getting 8 square root 2. So you may leave your answer in this form, or you can just calculate correct to 3 significant figures. Now part 2, the tangent to the curve at the point T parallel to AB. Find the coordinates of T. So now, when parallel to AB, that means here is A, this is B. So then, this is the tangent, right? So you need to find out the gradient, AB. So now I will rewrite my A with coordinates 1, 4, and the B is 9, 12. So now my M, okay, the gradient, MAB equals to y2 minus y1, if you still remember. So M is basically y2 minus y1 over x2 minus x1, given 2 points. So then from here, I use the bigger y, which is 12. So 12 minus 4 over 9 minus 1. This is 8 over 8, that is 1. Okay, I found the gradients AB, 1. That means gradient of tangent is also 1. So now gradients of tangent to the curve, we get it from the differentiation of the curve equation. This is our curve equation. So dy dx, you bring down the half, then x power, the degree always minus 1. So half minus 1 is minus half. Then from here, when I simplify, I'm getting 2 over square root x. Okay, so now 2 over square root x is same as 1 because they are parallel. Therefore, 2 is square root x. So to eliminate the square root, I square both sides. That means now here, I will be getting x equals to 2 squared, which is 4. Okay, go back to the question. We have found the x coordinate. But then now we need to find the coordinates of the points, which means we need to find the t, the y value, the y coordinate. And we see here, the tangent to the curve at the point t. That means this point t is also lies on the line or on the curve, right? That means now I get my y coordinates from the curve. So when x equals to 4, my y is 4 square root 4. That is going to be 8. Hence, I get my point t with coordinates 4, 8. So solve for this part. Now, find the coordinates of the points of intersection of the normal to the curve at t. Okay, normal to the curve at t with the line AB. So now I need to form the normal line to the curve at t. So now we have found this at t, basically at t, because okay, I have to find out what is the gradient of tangent at t first, right? So at t 4, 8. So at t with coordinates 4, 8, my dy dx, okay, go back to the previous question. It's mentioned that the gradient is parallel to AB. That means the gradient of tangent is 1 because the gradient of AB is 1 here, right? So now we need to find the normal. So m normal equals to negative 1 over dy over dx. That means it's going to be negative 1. This is my gradient of normal at the point t. So then I can just calculate or find equation of the normal at point t. Use this gradient and the coordinates of 4, 8 to form the straight line equation. So y minus 8, the gradient is minus 1, x minus 4. Right? So from here, y minus 8 is minus x plus 4. Hence, your y equals to minus 8 plus 12. This is my equation of normal. And now you need to find out the coordinates of the intersection points of the normal. So normal line is found with the line AB. Okay, just now we have not found the line AB yet. So now, your A with coordinates 1, 4, B with coordinates 9, 12, and then the gradient is 1 just now. So I can easily write down my line of AB. Okay, equation. of the line of AB, that is going to be y minus y1 equals to m bracket x minus x1. So I will use the point of A. So y minus 4, the m is 1, x minus 1. So here y basically 1 times x minus 1 is still the same. So x minus 1. So minus 1, move this minus 4 to the other side, becomes plus 4. 1 plus 4 is plus 3. This is my second equation. I let this be first equation. And now I need to solve simultaneous equations. Right, I will continue over here. So when I solve, I will just write first equals to second. So which means minus x plus 12 equals to x plus 3. So the x move to right side to get positive. The plus 3 move to left side. So when you move the minus x to the other side, it's x plus x, which is 2x. Then 12 minus 3 is 9. Therefore, my x coordinate is 9 over 2. And now, I will just refer to either first or second equation to find the y coordinate. So probably I will just use the second equation. So my y is basically 9 over 2 plus 3. So this becomes 15 over 2. Hence, my intersection point, right? Or you can write point of intersection. That is with coordinates of 9 over 2 and 15 over 2. So that's all for this question. Right, so we have come to the end of the video. So thank you for watching. Please continue supporting this channel by sharing this channel with your friends, and also stay tuned for more upcoming videos. Okay, thank you. Bye.